Okay, so the test, guys, tomorrow will be as follows. There will be two tests, one theory, one calc, as we have done all the time. The calculation, which is lighting, it will have 3 problems calculated exactly like the ones that I made a copy for you right in front of you. We're going to fill them in a second here. And also, William, my friend, there will be 15 fill in the blank. 15 problems fill in the blank. These 15 problems fill in the blank are coming from chapter 6 through 10 right here. Now, you guys, if you haven't given me your homework, please do so as soon as the end of the class, because I'm going to give you the answers for these. I have the answers for them. You can make a copy. Look at the answers of these. So the 15 problems fill in the blank are coming from the answers from the questions at the end of chapter 6 through 10. Any question about that? 15 of them. So there's 15 fill in the blank questions and 4 calculation problems. Any question, guys, about what the test is going to be about? Alaripo, 15 fill in the blank problems from the end of these chapter 6 through 10, and 3 calculation problem, and I made a copy for you guys, colored copy right in front of you. We're going to go over. Nick, cool for that one? Okay. The theory, I'm going to go over the theory afterwards. Cool? All right. So everybody's looking at this information, guys. This is a floodlight. I have a floodlight, just to give you an idea. I have a 20 by 20 area right in the middle of it, 20 by 20. I have a floodlight. Here's all the description of the floodlight, tau, my friend. I have coefficient of utilization is 90%. Coefficient of beam utilization is 44. Lumen depreciation factor is 70. Dirt depreciation factor 85. Lumens is 30,000 lumens. And the area is 20 by 20. And the question is, find the foot candle. Everybody, guys, is looking at the first page. You have all this information in front of you. That's why I expedite the process a little bit. Any question about the requirement? Any question about the requirement? So what my question for you is, we need to go find the foot candle. Find the foot candle. Any question about the requirement? I have a floodlight in this area with all this description. We talked about coefficient of utilization and beam coefficient of utilization. I don't want you to calculate them. They're already given to you. The only thing I want to find is a foot candle. Okay, so if you go back. These are from my, you guys don't have. Okay, here you go. So if you go right here, we need to find foot candle. The formula, guys, is lumens times coefficient of utilization, beam coefficient of utilization, lumen depreciation, and dirt depreciation divided by the area. Okay, let's do it. I'm going to go, so the first thing is lumens, it's 30,000, 31, 2, 3 times. Second one is coefficient of beam of utilization 9. The third one, beam utilization 0.44, and multiplied by, what else? I have lumen is 0.7 depreciation, dirt is 0.85, and everything here is divided by 20 times 20, which is the area. Any question? Straightforward, no gimmicks, nothing. And if you do the math on that one, the answer will be 18 foot candle. The average, and is this a maximum, the minimum, or the average? This is the average method. The average foot candle is 18 foot candle. Did they do the math right? Anybody? Thank you. Any question? That's problem number 1. How hard that would be?
And the height is going to take into consideration, I think.
The height, well, the lumens, the coefficient of utilization and the beam coefficient of utilization took care of the height for the fixtures. Yeah. That's the average method. Rob, because you have short memory, you have long memory and short memory. If you guys, it wouldn't hurt my feeling to bring the formula with you, but I don't want to see the example though. This is a floodlight calculation. How hard it is? What we did, we calculated the CPU, but we're not going to do it for the test. Any question? May I move to the next one? Okay, thank you. The next one, guys, is the following. I have, the next question is, I have a room. Whom am I going to pick up? Dustin, I don't pick up on you a lot. Dustin, I have a room. The room is 70 by 300. What a heck of a room, huh? 70 by 300 by 12, right? Length, width, height, okay? And for this room, I need to find the following. I need to find the following. Room cavity ratio, ceiling cavity ratio, and floor cavity ratio. But in order to tell you guys how to make that room, I also drew that picture, which you guys all have. I have the cavity ratio number 1 is that red. Can you guys see the red? Which is the height of the cavity is what? The height of the whole area is 12. 2.5 for the floor and 2.5 for the ceiling. That will leave me with 7 for the room, 2.5 for the floor cavity, and 2.5 for the ceiling. Any question, guys, about the height of the 3 cavities? Any question? Everybody understand what the RCR, CCR, and FCR, these cavities? These cavities will help us find the coefficient of utilization for fixtures. This problem is just purely about calculating them. Just calculating the cavities. William, my friend, any question about these? What's given? So tomorrow, what we're going to be doing, William, is change these numbers and do the calculation for you. I might not draw this for you. You have to be able to draw and know where the cavities are. But I have to give you, though, I have to give you the height of the ceiling and where I want the floor to be and where I want the ceiling to be. Otherwise, well, Chad, I want to put this one at 3. I want to put this one at 4, right? I'll tell you what the cavity is height. If I give you 2 cavities, height of the floor and the ceiling, of course, you can calculate the room, right? Any question, guys, about this? Okay, so what's the question then, Chad? The question would be is, could you please find this, and find this, and find this? Find these 3. Cool? Everybody understand what the problem is? What the challenge is? I hate to use the problem. Okay, let's go. Let's go do them. The most important thing, a lot of people, my friend, we need to find is the formula. Here's what the formula is. For the formula, 5 is always 5. HR is the height of the room because I'm calculating the room cavity. Width and length of the room added, width multiplied by length of the room. Always this way. The only thing that changes, William, the only thing that changes in this equation really is that baby here. Everything stays the same. The only thing that changes is the height. Is it room, is it floor, or is it ceiling, right? Okay, so let's go ahead and do it. Let's do it for the room cavity ratio. So I have 5 multiplied by the cavity ratio. The height of the cavity ratio is 7 for the room. And it's 70 plus 300 divided by 70 times 300. And if you have a good calculator, you should come up with something like this. The room cavity ratio is 0.6. Room cavity ratio is 0.6. If I did my math right. Any question, guys? Any question why 7? Because the height of the room cavity is 7. Now the rest of them, the only thing that's going to change is the height. So let me know when I can move to the ceiling. Yes, Alaripo? Okay, let's go do the ceiling. So, I'm sorry, go back.
I think I'm just typing in, unless you type in a calculator, keep going on the 35.
Did you add these 2 first and then multiply them by this?
Oh, no.
Yeah, can you guys see, I can't emphasize the brackets here. Can you guys see the brackets here? First you add them and then you multiply. The brackets, you're absolutely right. Can you guys see the brackets? Okay. Well, let's go to the ceiling. Now for the ceiling carry ratio, guys, the ceiling is 5, the same thing, 5 times 2.5. Why 2.5? Because the ceiling carry ratio is 2.5. 70 plus 300 divided by 70 times 300. And this came up with 0.22. And the floor carry ratio identical, 5 times 2.5 times 70 plus 300 divide by 70 times 300, and this, surprise, surprise, is going to be 0.22. Done. Any question, guys? That's it. That's question number 2 in the calc. Find the 3 cavities. I can't emphasize, the only thing that is changed for all of them is the height of the cavity. Everything stays really the same in the formula. The height of the cavity. Okay, let me know, guys, when I can move to the next one. So one more problem and then we're done for lighting. Again, before I will get you guys the answers for the 5 through 10 immediately after the class, so you can make a copy of that. You can look at it. I need homework though. Make sure you give me your homework. Otherwise, your homework will not be given. You're not going to get credit for the homework. Okay, here's the problem number 3. Problem number 3, my friends, is here's the following. I have a room. My room is 50 by 60 by 13, a 13-foot ceiling, and the width and the length. So this is width, length, height, right? My width, my length, and my height of my room, right? And then I, Chad Kerdy, decided single-handedly to use 2x4 fixture, like one above your head, because I'm going to put them in these rooms. The lumens out of each one of these lamps is 400, and I decided to use a 2-lamper, not 3, not 4, 2 lamps, and each lamp will give me 400. And I decided I need to maintain a foot candle of 90. I need to maintain a foot candle of 90 in the area. Okay, so what's the question, Chad? The question is the following. I need you first to find room cavity ratio, ceiling cavity ratio, floor cavity ratio for all of this. Then I need you to find the coefficient of utilization for this room. And I need you to find how many fixtures I need in this room. Now to do so, you need to have the light loss factor given as 70. And also reflection. Floor reflection 20%, ceiling reflection is 80%, and room reflection is 10%. The floor reflection is 10%. So we're giving all these reflection. Number 4, I want you to find the layout of these fixtures. So I have a floor, I have a ceiling, and I have a room or walls. Any question, guys, about these things in green? These are, why do I need this? We're going to use a table right now to find the coefficient of utilization. What do I need you to do to find these 4 things? Find the ratios, the 3 of them, find the coefficient of utilization, the number of fixtures you need in this room, and lay out these fixtures for me. Lay out these fixtures for me. Shall we do it step by step? Any question about what's given? Any question about what's given? This is what's going to be written for you guys in a different format tomorrow. So don't confuse. All right. The first thing, guys, the first thing I would do as the first thing I would do is I'm going to tell you guys in the test, it will tell you I have my fixtures recessed in the ceiling and I need my calculation right at zero, okay? Right at the floor here. So all what you're looking at, this is all room cavity ratio. Now my question for you, what happened to the floor cavity ratio and the ceiling cavity ratio? 0, 0, 0, okay? All right, so let's go find the room cavity ratio. For this application, the room cavity ratio, guys, is 5. The height of the cavity, I single-handedly, Chad Curdy, decided to make the height of the room 13. I don't want to care, I care less about the floor cavity and the ceiling cavity, right? There's no floor or ceiling cavity, meaning here's a light here, nothing above it, and I want to lit instead of 2.5, I want to lit right at the floor level, okay? So 5 multiplied by 13, the height of the cavity, and multiplied by 50 plus 60, and 50 times 60. And if you guys do the math on that one, this will be 2.4. The cavity ratio is 2.4, okay? Now, the cavity ratio for this baby is 5 times 0 multiplied by 50 plus 60 divide by 50 times 60, and anything multiplied by 0 is a big 0. Same thing, 5 times 0 multiplied by 50 plus 60 divide by 50 times 60, and that will get you a big fat 0 again. So these two are 0, 0, 0. We care less. The most important one that I really care about is right here. This one, this value. Any questions about this? Straightforward. Now, actually, if I don't tell you that the height of the room cavity is 13, you wouldn't be able to do it. On the test tomorrow, I will tell you that the height of the room cavity is 13, and the height of the room is 13. So what would that give you? Meaning the height of the ceiling cavity is big fat 0, and the height of the floor cavity is big fat 0. Any questions about this? We do this in hallways where we need the light to be right at the floor level. Okay, let me know when I can move. Move, yes, no? Alaripo, you good? Okay, let's go down to this. Now, in order to solve the problem tomorrow, guys, you have to have Fig 10.3. Either you open the book to this Fig, or I might give it to you printed. So you're going to go, if you guys go to Fig 10.3, page 84, you cannot solve this problem without looking at this graph. It just, you can't. Okay, so based on this graph, guys, I have, what was the room cavity ratio that we came up with? 2.4. Okay. Now, if it's not, we're going to see how we approximate it first. Okay, I want you guys, please go to Fig 10.3, page 84. Okay. All right. If you guys go there, it's 84 in the book. The floor reflection is 20. So the first row is going to be 20. Oh, one more time. Okay. I know where to find it now if I want to steal it. Okay, page 84. If you guys look at Fig 10.3, the upper left corner, the first row, can you guys see where it says floor RFC 20? Everybody can see that? Now floor is 20, done. Here's the floor. Right underneath it, ceiling, I have 80 and 10 and 50. What's my option? I'm sorry, the wall, the ceiling. The ceiling is 80. I have 80 or 50. What's my option? 80. So here's done. Here's 80, and the third row is the wall. The wall is 10. Bad reflection 10. So the wall is 10. Okay, now I'm in the last column of that area under 10. Now I need the coefficient of utilization. Look what my option is. 1, 0, 1, 2, 3. So I have 2 or 3. I'm going to approximate this one, guys, into, because 2.4, I'm going to approximate it to 2. Right? Because it's less than, so make it 2. Make it 2 because it's 2.4. Can you guys see the first column says RCR? I'm 2.4. I want you tomorrow to go, if it's 2.5, go to 3. Less than 2.5, less than 0.5, go down. Does that make sense? Make it a whole number. Okay? So if it's 1.5, becomes 2. 1.4 becomes 1. For the sake of the calculation. We don't want to do interpolation. Okay, so that would be 2. Can you guys cross-reference 2 with number 10? What was that baby? 0.59. Everybody got that? Done. 0.59. So that baby then my coefficient of utilization as my coefficient of utilization as 0.59. Does anybody wants me to walk you through how to find the coefficient of utilization? Coefficient of utilization is 0.59. Coefficient of utilization is 0.59. If you found the coefficient of utilization, we're done. Any questions about this? How to use? The most important thing is that fig here. Otherwise, you're not going to be able to use it. On the final, I'll get you a brand new one from Lithonia, but not this time. They're all the same. They go by the floor reflection, ceiling, and walls. Floor is usually neglected. Ceiling and walls are the most important things. Dark ceiling have a smaller reflection. Light color ceilings and floors have a higher reflection. Okay, can I move, guys? Yeah. Yes, no? Okay. All right, thank you. The last thing is find the number of fixtures. This is the formula that you're going to bring with you tomorrow. This is this formula. You guys are going to bring this formula with you tomorrow. Okay, so let's plug things in that formula. The foot candle was given as 90. Given. I want to maintain an average foot candle of 90. The room, the area is 50 by 60. This is how we find the area of a room, right? It's a rectangle. Divide everything by the following lumens. The lumens of the fixture that Mr. Curdy decided to use is 4,000 multiplied. I decided single-handedly to use 2 lamps. Tomorrow I can give you 5 lamps. Well, 4 lamps. So 2 lamps times light loss factor. That's taking into consideration all the derating factors. I'm giving you this baby as 0.7 multiplied by coefficient of utilization. Ashley, we just found it, 0.59. By the way, the whole mess here is to find the coefficient of utilization. I'm giving it to you. We found it as 0.59. If you guys do all your math, you're going to end up with 81.7 that approximate to 82 fixtures. 82 fixtures. Okay? $82 fixtures. I don't know if I did the math right. 82 fixtures. Now, Jackson, my friend. Any question?
No.
Okay.
Just got the same answers on the top.
Oh, okay. Maybe you're short 1-0 here.
Yeah, I was.
Okay. So this formula, please bring it with you to the test. If you memorize it, great. If you don't, bring it to the test. Okay. Now we're going to go find. We're done. The last thing I want to lay out these fixtures, guys. I need to lay out these fixtures. Now this is where you guys are going to be creative. Any questions about this? Let me know if I can move. The last thing, 82. Now layout. I want to remind you guys, we have how many fixtures? 82 fixtures. You guys remember how we do that 82 fixtures? To lay them out with rows and columns, actually, I want to ask myself, how many rows and how many columns do I need for 82 fixtures in this room? Okay, well, the only option I have is 41 times 2, or, God forbid, 82 by 1. Can you find any two? Can you factor these 82 numbers with other than these factors? 41 is a prime number. You can't factor it. That's okay. So here's my option. My option is 41 rows and 2 columns, or 82 columns and 1 rows. Both of them suck, right? If you look at an area, imagine. Okay, so I'm going to make an executive decision. Either go up or down to make my distribution. Now, I know it's 82 fixtures. I want to make an executive decision, guys. That's, again, opinion. And I'm going to drop one fixture here. And I'll make him 81. Drop one fixture, right? I'm just going to drop one fixture. 81. Now, 81 fixture. And you're going to know why I'm going to use 81. What's the two largest number you multiply by each other to get you 81? 9 by 9, perfect distribution. I have 9 rows and 9 columns, perfect distribution. In return, I lost one fixture. Who cares? It's all approximation. A one fixture in 82 fixtures is not a big of a deal, guys. Remember, we're doing it by hand approximation. I didn't go 83 because 83 will make it worse even. Is 83, I think 83 is a prime number too. Right? 83 is nothing. You know what a prime number doesn't divide by anything except itself and 1. So I went to 81. So tomorrow, guys, you're going to make your decision. If you end up with a number like 17, for example, what are you going to do? Make him 18. And have 3 by, what's 18 would be? 18 will be 4 times, drop to 16. Yeah, 16. It'll be 4 by 4. Yeah. It'll be 4 by 4. Absolutely. So try to adjust it to a number that can give you a good number. Okay, so I made an executive decision. I'm going to use this. Okay, so 81.
What you saying is that whatever number you pick,
yeah,
by your own opinion,
yep.
You're going to go by it.
But I don't want you to go from here to 100.
I know.
Yeah, you're going to go plus or minus.
Like the issue of 17.
Yeah.
You can go 18.
Yep.
And come 16.
Yes.
So,
what's your rule? Yeah, good point. If I can go up or down, where should I go? I always go up. Why up, guys? You have more light. If I can go up or down, right, and I get really good distribution, like 18 or 16, I would go 18. Go up. That's my rule of thumb. Okay. All right. So the rest is history. And tomorrow, guys, you're going to be laying out the fixture for your friend Chad. You guys have all this diagram. I want to remind you, this side is 50, and this side is 60. And then how many columns I'm going to have? I decided 9 by 9, so I'm going to have 9 columns, 9 rows. If you count, here's 1, 2, 3, 4, 5, 6, 7, 8, 9. The same thing, the rows are 9. In the center of every 9 by 9, you're going to have rectangles. At the center of every rectangle, you're going to have one fixture. Okay? So how do you find the fixtures? If you guys remember how we did x's here, I made x to x to x to x to x to x to x all the way to x. If you add all of them, this is 9 times 2x, 18. 18x is equal 20. Divide the 60, divide by 18 equals 3.3. So the x here is 3.3. The 2x will be what then? 6.6. Okay? Any question, guys, how to do that? Yes, sir. The width? Yeah. It really doesn't matter where you're going to, how you orient it. It doesn't matter. It's going to be the same, as a matter of fact. It really doesn't matter how you orient them. I orient them this way, by the way. See how I orient my fixtures this way? Because why do you think I orient them this way? Because you orient them that way with the longest length. But for the sake of the calculation, it doesn't matter.
If you have 18.
Thank you.
You choose
Yes. If it's not 9 by 9, see if it was 10, if it was 10 by 9, then I will have 10 columns and 9 rows because the 10 is the longest. Make sense?
Oh,
Make sense, guys? You have the largest number, rows or columns, goes with the longest side. In this case, it doesn't matter because it's a square, 9 by 9. Okay, so again, there's a 2x. If you add all the 2x's, 1, 2, 3, 4, 5, 6, 7, 8, and there's 1 and 1 here, that will make it 9. That's where the 9 times 2x equal 18, and x equals 3.3. Go down here, same thing. 2y, 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 y at the end, add them, 1, 2, 3, 4, 5, 6, 7, 8. 1 and 1 equal, they will be 9. So the same thing here, 9 to y equal 50, 2.8. So I'm going to go 2.8 from this side. So basically, and 3.3 from this side and put my fixture. Now I'm sure Phil is sitting there, yeah, good luck. What if the grid is different? What if your grid is different? This is beautiful if you don't have a grid. What if you have a grid? Then you adjust you know where you should be, right? You should be basically 3.3 by 2.8. That's what you want to aim for. And then you kind of adjust your system to fit in the grid within these parameters. Any question, guys? I'm looking for, yeah, I would like you guys to draw the same thing tomorrow. Is that hard? Dustin, does it make sense? No?
so 3.3 is the width of each section.
The 3.3 is the center of the fixture. From here, let me just go with the black here. The 3.3 is from here, the center of the fixture, to this side. This area is 3.3. The 2.8 is from this side to the wall. This is the, what is that? 2.8. 2.8. The x and the y to the center of the fixture. To the center, like if a fixture like this, where would you start? You will start from here to the center of the fixture. In our case, what was it? 3.3, the x? 3.3. So here's a 2, and here's another 1. So this is exactly what 3.3 would give you, right? Because if you take here's 2 feet, another foot will give you, this is a 4 foot, right? Almost in the middle there, 4 foot. You need another almost. So you want, this will give you almost there, right? To the center of that fixture. But again, if that's, I need 3.3, but I couldn't get 3.3, then you might have to adjust it to fit that grid that you have. These are all approximation, guys, to start where you don't have to, we don't know where to start. We're going to start. Any question? Okay, so you guys will continue. All your fixtures, obviously, is going to be right in here. All your fixtures, and I'm not going to draw all of them. And tomorrow, I don't want you to draw all of them, guys. 82, 81 fixtures. Okay. Any question for Chad, guys? All right. Let's do a review for the other test. And then we'll here's the answers for 6 through 10, guys, right here. So I want, if you want to look at them. Okay. Can we switch track, guys, and move into theory? Can I? All right, ready? Any question about lighting? So lighting is going to be 15 problems, fill in the blank, and 3 problems calculate. You saw the 3 calculation problems. Fill in the blank. They're right here. Make sure you review these, and you're good to go for, you will get your D- and move on. Oops. Nobody's smiling, man. It's supposed to be a joke here. Okay, let's do theory, shall we? All right. Theory. What I'm going to tell you guys is focus on, obviously. That theory test is going to be from chapter 6 through, from chapter 11, from chapter 11 through 15. 11 through 15. Cool? 11 through 15. Okay. Lighting control. Methods of controlling lights in a commercial building. For example, across the line, photocell is an example of this. Methods of controlling lights in a commercial building. In a commercial building. Oops. Non-recognized. Sorry. Okay. How do they, generally speaking, how do they heat a commercial building? That's from the chapter that talks about boilers. How do they heat a commercial building, generally speaking? These are all multiple choice, guys. When we use boilers to heat a commercial building, when you use boilers, want you to research that. When you use boiler to heat a commercial building, they look at the outside temperature and they start the commercial building if the outside temperature reach a value. Fahrenheit. Is it 60 Fahrenheit, 70, 90? 90 Fahrenheit to start the boiler. So what is the temperature, the outside temperature, that the boiler, its sensor outside, if the temperature is that value, the boiler inside the commercial building will start. This is in the commercial building boiler. When you go there, it will talk about the outside temperature that triggers the boiler to start. Why do we identify if you have if you have two voltage systems in a building? This is simple answer actually. If you have two voltage systems in the building, by code you have to identify, color code all the conductors of the branch circuits and the feeders for the two systems, 480, 277, 28, 120. Why do you think we care? Anybody know the S word? Safety. The last thing you want to do is to take a phase A from 480 and tie it to a neutral of the 208, and you get a voltage of 300 some weird voltage burn equivalent. Color code, this is not code again. The color code for 480, 277 and 28, 120. What are they? It's not code, it's industry standards. If you have a 28, 120 three-phase system and a 480, 277, they use conductor colors. For example, red, white, blue, and brown, and yellow. What are the colors that they use with the 208, 120 and with the 480, 277? It's in one of the chapters that talks about service, guys. The chapter talks about service. We remember the working space, guys, and dedicated space. Working space around the electrical equipment and dedicated space. Please understand how to find the working space and the dedicated space around the electrical equipment. I will give you a voltage and I will tell you what is a multiple choice. The working space in the front of this piece of equipment is 3 feet or 3.5 or 4. So you're going to go to the chapter, the service again, that talks about working space around electrical equipment and dedicated space. The height of the working space, the height of the dedicated space, the depth of the working space. Working space, very important to review the working space and dedicated space. There's a few questions about that. I want you to know that because it might confuse you. If you have a service, Ashley, that's medium voltage, higher than 600 voltage, medium, higher than 600 voltage, there's a code that we use. It's called National Electric Safety Code. Remember that one. If your service is higher than 600 volt, you have to adhere to a different code too, especially the utilities, mainly the utilities. It's called NESC, National Electric Safety Code. NESC. Utilities use them. This is their Bible versus our Bible is called NEC. Theirs is NE and they add an S. NESC, National Electric Safety Code. They'll ask you guys about the service point. What is a service point? If they have a service point, you're going to go to the definition in the NEC code book at the beginning. The service point is defined in the NEC code book. Also, service conductors, service point and service conductors. And all these are defined. You don't have to memorize them. All in the NEC code book, Article 100, service point and service conductor. And there's a difference between service conductor and service entrance conductor. And service lateral and overhead service lateral. All these are in the so please pay attention to the word that they use. Do they say service conductor? Get the service conductor. If they say service entrance conductor, is different. Grounding electrode conductor. Can you splice the grounding electrode conductor that's going to the ground rod? Generally speaking, no. The grounding electrode conductor and the bonding conductors, guys, the system bonding jumpers, we don't splice them. If you splice them, though, it has to be irreversible, meaning it's not, I can't go unscrew it. So remember one thing, grounding electrode conductor must not be spliced. That's the general rule. The exception, if you splice it, then it has to be irreversible. Okay. The second thing is ground fault protection for equipment, GFPE. Please pay attention to GFPE, ground fault protection for equipment. This protection is required on any system 1000 amp or higher, and the voltage is 480-277. What does it do though? It protects you from ground faults, not three-phase, not phase-to-phase, ground faults. Any phase to ground, it will protect you. So it's called GFPE. It protects you from a ground fault. So remember that one. We talked about this, guys, today. Because of the hazardous nature of fluorescent lights, EPA, Environmental Protection Agency, US EPA, involved. So remember, it will tell you if the lights have some toxic material in it, like mercury, then which agency regulate the disposal of these equipment? It's called EPA, Environmental Protection Agency. This is one of the one of the agencies that.
One of the many agencies that have Harold's money.
No, and one of the agencies that some of the candidates for the presidency now wants to cut. EPA. As of now, you have to stuck with it. EPA. Please understand the definition of a slim line lamps. This has slim, S-L-I-M, line, L-I-N-E, lamps. These are, back to your question, Tao, these are associated with the single pin base for the fluorescent lights. And oh, by the way, the single pin base goes with instant start. They say it's associated with instant, not rapid start. These are rapid start. Instant start, they have single pin. So what my question for you is slim line lamps.
So then they would be more expensive type of lamp.
Yeah, instant start. That's probably why we don't use them that often.
Yeah.
Instant start. So slim line lamps associated with instant start and one pin, PIN base, one PIN base. How do we correct power factor? If you have a power factor problem, how do you correct it? You add inductance or capacitance? Capacitance. We add a capacitor to correct power factor. Today, guys, I showed you a table that compare between all the types of light lamps: incandescent, fluorescent, metal halide, mercury, high pressure, low pressure sodium. It compared between the efficacy, the lumen per watt, the life expectancy, and all this stuff. Could you please review that table? The table that compares between the three types of lights, well, six, almost seven type of lights, in terms of lumen per watt. Which one of them is the best lumen per watt, basically? Have the longest life, and so forth. There's one question about that. In particular, because there's so much, I don't want to memorize all of this. In particular, Phil, pay attention to metal halide, will you? In particular, pay attention to metal halide, because there's a ton of them. And I don't want you to memorize all of them. CFLs, you guys know what CFLs are, and LEDs now. CFLs is compact fluorescent lamps, right? And LEDs are in a lot of application are taking the place of the incandescent lamps, especially the CFLs. CFLs are replacing the incandescent lamps because you have the Edison screw and base that you can put it. So remember, CFLs are taking the place of the incandescent lamps. The definition of a multi-wire branch circuit. This is again from the definition 100. What's a multi-wire branch circuit? You have two hots and a voltage to ground, two hots. Each one of them has equal voltage to ground with another third conductor, which is a grounding conductor. We talked about this today, guys. In a clothes closet, what type of fixtures is allowed to be installed? And also the clearances. And I summarized it to you today. I said everything is 6 inches except surface mounted LED and incandescent. They're 12 inches. All other types are 6 inches. We can't open incandescent lamps, open lamps, guys, pendant lamps, and open lamps that doesn't have a globe over it. You can't install it in an incandescent lamps. The picture I showed you guys, please review it. What type of fixture you can install in a closed closet, and that closed closet could be in your basement or your house, or it could be here at Dunwoody. It doesn't have to be, as long as it's dedicated for clothes. This question, guys, is about the project that we have. It's in a commercial building that this project is following. The owner circuits, their owner circuits. What do you expect the owner circuits to feed? Common spaces, right? If you have a multi-occupancy building, a building owned by one guy, rented to multiple people, the common spaces, they feed them from a common panel. So the owner will pay for it. So owner circuits in this project is feeding the common spaces, as in hallways, bathrooms, heating for the building, and so forth. This is about the chapter that talks about motors and control, guys. When we have pumps, what are the control elements of a pump? I can give you a hint. Control elements of the pump, when we have a whole pump, you need what? We need a contactor, overload with a contactor. These are all part of the control and protection element. An overload protection, a fuse, a contactor, they call them input devices or pilot devices like a floating switch. So if you are to be asked about what are the elements of a control for a pump, contactor is one of them, overload, overcome protection device, fuse or circuit breaker, flow switch could be big part of it. There's one question that the younger ones might not pay attention to. The question talk about the difference, the difference between the panel definition today and in the past. The reason why they do this one, guys, because in the past, for some of us who have been using the code, they used to define something called lighting and small appliances panel and power panels. So I'm giving you the answer. In the past, they used to call the panels two types. One is power panel, and the other one is lighting and small appliances. Who cares? Remember that term, who cares? Who cares? If it was lighting and small appliances panel, you're limited to 42 slots, circuit breakers in it. If it's power panel, the limit is the sky. In 2000, what was it, 2008, I think, or 2005? Now I'm confused. Somewhere in the last two cycles, they got rid of this. Now a panel doesn't matter if it's lighting and small appliances or power panel, it's a panel. And is there any limitation on 42 circuit breakers anymore in the code? No, no limitation. So some exceptions, one or two, but no limitation for the most part. Gentlemen and lady, this is all I have. You guys are going to get A tomorrow. We're going to start at 8:30. We'll do the test. If you need more time, you can come with your friend Chad and continue. At 11 o'clock, we're going to leave to Halberg, guys. Hopefully, we'll continue working on the project today. Thank you. That's all I have. Any question, by the way? No. I have the answers here. I'm going to leave them here. If you guys did the homework, please give it to me, as soon as you can. Thank you.